All right. Hi, everyone. So, like I said before, I'm not going to be here today. So, you're going to be looking at my lesson, going through your notes, and making sure you write down whatever you need. If you need to go faster, again, you can always fast forward, go through this, but I'm going to go through this relatively quick. If you need some more time, you can always pause it and go back. So, do what you need, but make sure that you understand the lesson for today. So, we're going to start today, all right, with our warm up. So it says two seagulls dive into the ocean. The given functions represent the height of the seagull above the surface of the ocean as a function of the seagull's horizontal distance from a certain buoy. For each set of functions, determine which bird descends deeper into the ocean. So what you're going to do is you're going to pause this in a second and you're going to go through the following problems, all right? And you're going to determine which function, f of x or g of x, goes deeper, all right? So make sure you do that. Pause the video and then play it when you are finished. All right, so you must have finished right now. So what we're going to do is we're going to get started on the function. So if we look at number one's function, this is actually f of x. This is a parabola. So this right here, we can figure out which one descends deeper by looking at the vertex. The vertex is, for f of x, our vertex is 2 comma negative 5. Remember, it's h comma k, so you take the opposite. You take the opposite of negative 2, which is 2. Negative 5, that's your k, so it's down 5. So this is what we're really looking at. We're really looking at it dove down 5 below the sea level. All right, g of x, if we look here, we have some points. So what we're going to be looking at from these points is which point goes down lowest, and that is this point, negative 6, negative 4, and the lowest it went was negative 4. So between these two, which went lower? The answer is f of x. All right, so now number two, so this is kind of how it's going to go. So I'm going to go a little quicker now. So number two, f of x. Now this function, you're going to actually have to plug into your calculator to figure out your vertex. But for me, all right, what I'm going to do is I'm going to tell you what the vertex is. You're going to go negative b over 2a. So you're going to go 12. Ooh, that's the wrong color. Here we go. So it's 12 over 2 times 3. So you're going to get 12 over 6, which is 2. So that's your x value. So your x value is 2. And we're going to substitute this stuff in here. So we're going to get 3 times 2 squared minus 12 times 2 plus 7. So you're going to get 4 times this is 12. Then you're going to get minus 24. And then you're going to get plus 7. So you'll get up here negative 12 plus 7 is negative 5. So that's your well, your lowest point. For f, that's your vertex. Then for g, it's already written in vertex form, so this is negative 2, negative 6. So which went lower? The answer here would be g of x, because it went lower. It went negative 6. Now, the last one, number 3. So number 3 gives you a function in standard form. That's f of x, and g of x is actually a table. So with this, what you're going to have to do is, for the f of x, you're going to have to figure out your function either by doing it by hand or doing it in your calculator. So again, for me, all right, I'll show you using the calculator what you're going to do. You plug it into your y equals here. All right, so we go on here. We're going to go 2x squared minus 8x plus 11. Come on now, plus 11. And what you're going to do is you're going to graph it. You're going to see where your vertex is, and from there, what I'm going to do is I'm going to calculate my minimum, my vertex. That's what we're looking for here. So we're looking for the minimum. So I go left bound, so 0, negative, or 0, 11, that's on the left, and then we got to go all the way to the right. Where is that? All right, so now we're to the right, guess, enter. So you get 2, 3. So for f of x right here, this is 2, 3. That's our vertex. So the lowest it went was 3. And now here, what we're going to do is we're going to look at what the lowest y value is here. And the lowest y value is this coordinate, which is at 2. So which went lower, f of x or g of x? And the answer is g of x. So that is really the grand scheme of today's lesson. You're really going to be comparing whether we're talking about vertices, whether we're talking about x-intercepts, y-intercepts, or your vertex, maximum, minimum, which one's higher, lower. That's what you're going to be looking at today. So, all right, let's do a quick little review. Which quadratic function has a greater y-intercept? So if you're looking at f of x and g of x, you have to know what you're looking at first. So if you look at here, y-intercept, your y-intercept, that's what I'm looking at. That's it. I don't care about the vertex. I don't care about anything. So in f of x, here's my y-intercept. g of x, here's my y-intercept. So which one has a greater y-intercept? That would have to be g of x. G of x has that. So that's just vision. I'm just looking at this. For the second part, which quadratic function has a greater vertex? So here I'm just going to look, okay, vertex, that's up here, a vertex that's down here. So which has a greater vertex? Which one has a higher y vertex? So when you're looking at that for the vertex, you're looking at the y value. What is a greater y value? And for that, that's going to be this guy right here. So you're going to say f of x would have the greater one. So this is basically what we're going to do. You're going to compare either vertex or y-intercept. So let's go to the next problem. So now in your book, you should have out page 121 now. All right, so here, our first example, it's kind of scaffolded with how you should think. All right, it says which function has a greater y-intercept? F of x or g of x? So f of x, that's a linear function. So this is linear right here. All right, and g of x, this is quadratic. So first off, you got to say, all right, if I'm trying to find a y-intercept, I can do this one of two ways. I can use my calculator, or what I can do is I can think and I can say, all right, what do we know about all y-intercepts, which is written here in red? What do we know about them? That's your general observation. Well, what we really know is that the x value will always be 0. So if the x value in your y-intercepts is always 0, you could actually calculate it by hand. You could actually plug 0 in for x in this first equation. So if I did f of 0 here, I could go 8 times 0 minus 2. Well, 8 times 0 is 0 minus 2. So my y-intercept here is 0, 2. That's for f of x. For g of x, I can do the same thing. I can go g of 0, and I can go 2 times 0 minus 3 times 0 plus 1. And again, I just simplify. 2 times 0 minus 3 is negative 3. 0 plus 1 is 1. 2 times negative 3 is negative 6 times 1. So my coordinate is 0, negative 6. So let's just ask the question. What has a greater y-intercept? Which one? Well, it would have to be f of x. And right there, by showing your work here, by showing this, let me try to highlight it for you, by showing this right here and this right here, and then making sure that you answer with this, you're totally good. That's all the work that I really need to see. And that's it. That's a great job. So let's do a couple examples and then you can start your homework. So here's more examples like how you will be seeing it on your homework tonight. So it says 3 students are shooting wads of paper with a rubber band aiming for a trash can in front of the room. The height of each student's paper wad in feet is given as a function of time in seconds. Which student's paper wad flies the highest? All right, so now we have a sub here. We are not doing this in class. You're not practicing it. We will do this when I get back. We can have some fun with this. But right now, we're going to determine, does Alejandro, Marissa, or I thought there were 3. Well, it's just 2 right now. Which one will fly the highest? So flying the highest, we kind of have to know what it's saying. Flying the highest here. So does that mean a greater y-intercept or a greater vertex? And here it's a vertex. And in reality, you're really looking for the maximum, the max of our function. So here we go. The path of Alejandro's paper wad is modeled by the equation negative x squared plus 2x plus 7. So here, what you're going to do is you're going to type this in your calculator, and you're going to figure out what this what this vertex is, which I believe I have right here. The vertex, when you plug it in and find your maximum, will be 1/8, which means after 1 second, Alejandro is 8 feet high. His paper wad is 8 feet in the air. Now, Melissa, the one in green that I have under here, Melissa, all right, her paper wad is estimated to reach the height shown in the table below. So here, what you're going to do, because there is no equation, there's just a table, you are going to take the table to be the truth. All right, so you look and you say, all right, what is the highest y value? Because we're looking for the highest point, and that is this, 3,7. So 3,7, that is your maximum. That's doing all that hard work to find your maximum. So 3,7. So now we say, all right, if Alejandro's was 1/8, Marissa's is 3,7, which one is highest? After 3 seconds, the paper wad achieves the maximum height of what? All right, so who's got the highest one? Well, Alejandro has the highest one. His paper flies the highest, all right? He flies the highest. And actually, I just see it right now. After 3 seconds, it says Connor's paper wad achieves a maximum height of 6.5 feet. So that was actually another one who was in the mix, but his only went 6 feet high. So he was actually the lowest height of the paper wad. So he wasn't even in the mix here. But that's how you look at them. You're either going to use your calculator, or you can really just look at the table to calculate it. So that's example 2. Let's take a look at example 3 now. So it says, which of the following quadratic functions has a vertex with a larger y value? So again, this is saying what has the largest maximum, All right, what is the largest vertex? So f of x, if you look here, is 2x squared minus 12x plus 25, or g of x in the table. So in g of x, what I'm going to do is g of x is easiest. I could actually find this one. I can find my maximum first because I just look for the largest. Nope. Ooh, that's larger than 7. Nope, nope, nope. It must be this guy. So my max here for this guy is negative 3, 8. So I know that's my max. But I need to find the max of my quadratic function, which is written here for f of x. So there, what you're going to do is you're actually going to plug that in your calculator. You're going to adjust your window and find your maximum. All right. I don't think I need to do that. We've kind of done that for a while. So over here, I have that written down here. So f of x, after using your calculator, will be 3, 7. G of x is going to be negative 3, 8. So we're all very intelligent people here. Which will have a larger y value for your vertex? And that answer is going to be g of x. That has a vertex with a larger y value. And that's how you answer it. So you just have to tell me what f of x is, g of x is, and boom, you're done. All right, good. Now, we've done 3 examples, 1, 2, and 3. Let's do one more, and then you're going to start your homework, all right? Now, do not rewrite this. Notice I write on the top here. Do not rewrite it. It's already in your book. Don't get crazy, all right? It's all here. I just want you to pay attention, all right? Now, you're considering investing $5,000 in one of 2 mutual funds. The first fund will pay $500 each year. The second fund is predicted to have an end-of-year balance shown in the following table. So this is your second fund. The first fund, well, they kind of told us right here. It said the first fund will pay $500 each year. And really, I'll write that up here, year. So that is your first fund, so $500 each year, which we actually could write out as this function, 500x, and x being years. All right, so which fund, so now I'm reading here, which fund should you choose if you want to withdraw your money after 5 years? And which fund should you want to choose if you invest your money for 10 years? So now it's asking us to compare at 2 different rates. So what we're going to have to do is we're actually going to need to find out how much you have in 5 years and how much you have in 10. So let's start with 5. Let's start with this purple one in 5 years. Well, let's start. If I want to figure out how much I got in 5 years, so here's my 5-year value. All right, we're going to have my first fund, I'm going to have here, and my second fund here. Now, one of these right now I can figure out what I have right away, and that's the second fund. Notice in the table, boom, 5 years is listed. I'm going to have 7 G's, or $7,000 here. So I got $7,000 in year 5, all right, in the second fund. But in the first fund, I'm not sure. But since I wrote this equation down, since I figured out the first fund will pay $500 each year, what I can do is I can substitute 5 in for x. So what I'm going to do is I'm going to go 500 times 5. Now I'm going to get 2,500, or $2,500. So in 5 years, which fund is best to choose? Well, in 5 years, I would choose, because I like money and everyone else does, all right, I would choose the second fund. Because clearly $7,000 is greater than 2,500. So that's in 5 years. But now we have to do 10 years. So 10 years. Now, all right, we have our first fund and our second fund. All right, now, first fund, again, is an equation. 500 times however many years, so 10. So 5,000, or 500 times 10 is 5,000. All right, now, all right, hold on, let me look back up here. I feel like here. Oh my goodness, I totally messed this up. All right, here's the thing. All right, so what it's doing, and I screwed this thing up. It's not 500x. Let's go back. Good Lord. All right, so let's go back. So I didn't read this correctly because you start with $500. You're actually, it will pay you an additional $500 each year. So when you do this, the equation isn't 500x. It really should be adjusted as 5,000 plus 500x. That should be the equation. So in here, what I really have to do is I have to add, I have to add an additional $5,000 to my fund. So I'm going to add $5,000, all And oh my goodness, that changes the entire thing here, because really, now I'm not going to want the first fund. I'm gonna, or not the second fund, I want the first fund, because that has an additional $500 in there. So my bad on that one. So here we go. So let me go back to year 10. Here we go. Now we'll do it correct. So now the first fund I can do, because I do have an equation. It's $5,000 plus 500 for every year, so 10 years. So we simplify this. We go 5,000 plus 500 times 10 is 5,000. So I'm going to end up with $10,000. Now that's a lot of money. But our second fund, we still need to know what it is. Now notice, our second fund, it only goes up to 5 years. Well, right now we're in trouble. Unfortunately, right, they didn't give us an equation, but they did give us some numbers, and maybe we can see a pattern here. So what I will do is I'm going to look, my years go up by 1, 0, 1, 2, 3, 4, okay. But my money, how much I'm going to have is 5,000, and this goes up by 200. And then 2,000 or 5,200 to 5,500 goes up by 300. And then this goes up by 400. And this goes up by 500. And this is 600. So if you notice, there's a bit of a pattern that's occurring here. All right. So what I'm going to do is I'm going to actually use this pattern to figure out how much I'm going to have in year 10. So in year 6, I'm going to have to add $700. So I got 7,700 in year 7. Now notice I kind of want to draw this out. In year 7, I got to add $800. So it's going to be 8,500. In year 8, I got to add 900 now. So I'm going to be at 9,400. In year 9, I got to add 1,000. So I'm going to be at, sorry, that's a 1,0400. Oh my gosh, I'm running out of room. Sorry. This number, let me move this all down here. You gotta love that I'm doing this on the fly. All right. So in year 9, it's 10,400. And then in year 10, because we added 1,000, the next one I got to add 1,100. So my total is going to be $11,500. So that's year 10, and I calculated using that pattern. So in the second fund, I can say here, all right, I will end up having $11,500. So now we say, which would you choose, the first or the second fund? And it's a no-brainer. It's the second fund, because you're going to end up with an additional $1,500. So you would say, I choose the second fund. So we made the correction on the first one, all right? And that's how you look at it. You just look for a pattern, or you use an equation, or you use your table, all right? And if the table doesn't give you your ending values, they're going to give you a pattern for you to figure out what the X number of years would be. And trust me, they wouldn't go any further than 10 or make you find 5 additional values. So what are you doing now? So we're 18 minutes into class. What you are going to do is you're going to work on page 125, 126, 4 through 9. All right. Not a lot of homework. It's 7 problems. All right. I want you to complete that. Make sure you're checking your answers in the back of the book. All right. And then be ready to ask some questions on Tuesday when I get back. All right. I'm sorry that I'm not here. Hopefully this works. If you have any questions, I will be back. I'm flying back home tonight. So I will be in school Tuesday morning, bright and early. So if you have any questions, you can come and see me at 7. All right. Have a great day. Be good to the sub, and I'll talk to you guys later.